Okay, this is the structure of a build right here. These are the steps. So when you look at the build script in source, know that this is what it's doing, okay? And the private build and the continuous integration build leverage the same build script. They have slightly different purposes. The private build is meant for the individual software engineer's workstation. That's where the private build lives. So we take the build script and we run the private build locally. And if you think about the notion of test-driven development and its definition of a single test, then you come away with the notion of arrange, act, assert, or set up and get ready, then do it, then check what you did. Okay, those are the three concepts. So arrange is set up and get ready. On the local developer workstation, when you clone the code, set up and get ready includes making sure that this application's dependencies are available. What I just showed you earlier was this application had a dependency on having a SQL Server database. It was something that the application it was a dependency and it needed it. And so guess what? The build script is responsible for creating that database locally. If the application is exporting some files to a directory, well, then we need to create those directories and know what the path is to them on a disk that we can get to locally. The best mindset for a private build is don't have it rely on the internet. You should be able to put it on a thumb drive, send it up to the moon, run it on a computer in zero gravity, and the private build script should work. You don't want to require the internet to be up and some shared server or some shared thing to be up in Azure or in your company's network in order for one of the steps in the private build script to complete. Recipe for disaster. Put everything locally. This is why it's called a private build. Private, not shared build, private build. Okay. This, you've probably heard of the inner loop of things that a developer does over and over and over and over and over again. The developer can spin and cycle. And then the outer loop is interact with the team. And then further from that, the team interacts with other departments, maybe product management. And then further from that, product management decides to send this version of the software out to its customers. And then further from that, customers are using the software and they encounter something and they provide feedback. Well, now that feedback needs to get back to the loop of product management, and then that feedback needs to get distilled, and product management needs to tell the team something that in the inner loop. And then finally, the team needs to decide what to do about it. And finally, there's a task, and the developer takes the task, and the developer is spinning on the inner loop and changes something about the software. And then there's some tests. So those are the inner loops. The private build exists for that inner developer loop. Okay, no dependencies on the outside. Now, the continuous integration build is for the team, okay? It's for the team. And whereas the private build kind of answers the question, I've done some stuff. Do I still have a stable code base or did I totally break it? Should I commit and push this up to my feature branch to have the feature branch pipeline even run, or is it a waste of time because I totally broke something, okay? The integration build answers a different question. The integration build answers the question, do the changes that work locally, when mixed with the changes that other team members have done, are those still good? Does it still result in a stable piece of software, or have the combination of those broken something? And now if I submit my pull request and get it merged into master, have I broken the software for the team, or is the software still stable and worth creating a release candidate build, right? That's the type of question, but it's the same steps. We clean the environment, then we stamp a version number so that all the assemblies have the version number. Then we set up environment, migrate database, talked about that. Then what's the core thing of a build? What are we trying to do? Compile. We're translating the text code, the code in C#, and we're compiling it to assemblies. We're compiling it to DLLs. Then once they're in DLL form, we can do some assertions. We can run some integration tests. We can run some integration tests and unit tests. And then after that, Then we say, you know what, the build is good. And now we have some additional steps that only run in the integration build environment. And that is static code analysis for some additional quality checks. And then we publish the test results, and then we package up whatever projects are targeted for deployment to ultimately to production. And then we publish those packages. Okay. All right. Let's see. I'll pause. Get a couple questions here. One from Daniel. To be completely private, sometimes we need to mock a server to not call some third-party APIs. Yes, absolutely. You need to simulate some dependencies where in a deployed environment, yeah, we call out to a third-party API, but locally, if we want to run tests against something locally and have those run in our build, absolutely, we can't call out to that third-party system. We need to use some good old design patterns so that we create a simulation of calling out to that server. We're not going to stand up a third-party server local. Like for instance, if I was calling out to a web server to make a web server, a web service call for weather information for weather.com, I'm not going to try to set up something that actually simulates weather.com. Instead, I'm going to set up some code that is a stand-in for the class that is the gateway that calls weather.com. And I'll set up an abstraction, most likely an interface called, I don't know, iWeather Gateway. And there'll be one implementation of that interface that calls weather.com. And then the other implementation of that interface would be called Weather Stub. And there's whole books that are written on test doubles and simulators and classes that can mock up different functionality. And so there's lots of information out there, but ultimately you need to simulate something. You need to act as if the gateway needs to be swapped out so that your application is still calling the abstraction that you created in front of the third-party dependency. But the rest of the application doesn't even know that it's running locally. All right. Kevin asks, our team has used Cake for years. They're happy with it. However, we're starting to remove it to go to pure PowerShell. The reason is we thought the team would like it and it would be easier to learn and maintain since it's C#, but it didn't happen. So we decided to recently remove the extra dependency. PowerShell is now cross-platform, and so you've gone to PowerShell. Good. Hey, good comment. Thanks, Kevin. I appreciate that comment. Yeah, good to know. But I've loved just regular vanilla PowerShell. It's a great scripting language, and yeah, it works great.